Okay, so second part of the exercise number 6. So when we are still here in this calculation of pi, starting from the serial version of the code, and we want to now do this in MPI. So first thing that we always have to do is we have to include MPI, otherwise we can include, so do it properly, include MPI dot h. So that's the first thing that we always have to do. So then before we come to the actual task, we'll have to do what, again, we always have to do in MPI. And so there are three things that basically we always have to do.
For the headers in it?
Okay, so now, yes, so the header is number 4. So, okay, init, yes. So we have, right. So we always have to start with init, yeah? MPI init. And we usually give this takes 2 arguments, and we take the arguments of the command line arguments, which sorry, this happens if you read from your cheat sheet in the wrong place. Yeah. No, we what I wanted to say is we give the reference to the number of arguments, command line arguments, and to the actual arrays command line arguments. This is right.
What S-batch is doing, right? It's running this and passing these arguments which probably contain which process it is.
Yeah, not really. Yes, I mean you can do this with this, but this is not happening, because what basically is happening is this is calling this function this way.
Yeah.
So you can put.
Not you, but inside of the runner, something is being passed because you are passing this through to the.
Yeah, but we always do this. So there's no. Yeah. Okay. I would have to look up what this actually does, because I don't know myself. So the basically you could initialize it in some non-default way, is what it means. Yeah. So this is number 1 that we do. And then what else? So basically this is what we have already up here. So we have a number of processes, and we have my rank. Yeah? So we have to get this somehow. MPI. So what do we do first? Say we do the first the rank. So rank, we need the communicator, the word communicator. And this we put, okay, we always communicate by reference with MPI, yeah, with my rank, okay? So, then we also need the size of our system. MPI com com size. It's basically the same thing. MPI com world, and here we'll have then this number of processes, right? Okay, so now we've set up our system. Now a lot of what comes later is already, so this exercise is only about using the master slave, not about how to cut things up, because they are already cut up for you here, right? So we already get a smaller part of this, and we determine by my rank, where we want to cut. Now, the only thing that we still have to do is to do the receiving and the sending, and this is basically here now in line 42. So how to do? So master slave means we have to distinguish between whether we are a master or a slave. So how do we distinguish? If my rank is, so what do we want to do first? Master or slave? Okay, so master is if it is 0, right? So what does the master do? What does the master do? Actually, master is more complicated. So the master asks all the slaves, right? So we need to have a loop for, okay, and I need a cheat sheet. So for, so we start with 1. Say, okay, and so the master receives information, right? So say it receives from the source ID, and the source ID starts from 1. Then this source ID needs to be smaller than what? Number of process. Don't trust artificial intelligence. And then we count this up. Source ID plus plus, right? Oh, yes, don't trust autocorrect, yeah? Number of no, autocomplete, autocomplete. So now I think this autocomplete was correct. Yes, so Okay, it's not, I'm not professional here, apparently. Okay, now we have to do the receiving. MPI receive. So we need a place receive. We need a place to receive to. Yeah. So I think this we have first we have to do this first. This is we need a we calculate in double. I think it's in double, right? Yes, we calculate in double. So I would say we initialize receive buffer. Okay, let's put this receive buffer to 0. Okay, so we have to receive something in. So we receive in our receive buffer. So what comes next? Int count. We take one value, right? Then data type is apparently double. We have double. So then the next thing, source. This would be source ID, right? And then we have, as the next thing, we have a tag. Oh God, the tag, we do not specify a tag. Let's say the tag is 0, but then we have to remember that it is 0. And we need a communicator. This is MPI com world. You know, the strange thing is that the one thing that you need the most often is the one thing where the autocomplete never works. And we have to need a status. Okay, so the simple thing is if we ignore the status, we could do MPI status ignore. What's the difference between this ignore and that status is ignore? Okay, so status ignore. So then we ignore our status. So now we did our receiving, I guess. Okay, so the receiving in itself is of course not sufficient. What I guess is we have to also put this into our actual result. Okay, so when we put it in the result, then the following happens. Let me see. Local integral. Okay, so right. So when the master works, so when we now say result is equal to no. Did we initialize result with 0? Hopefully, yes. So if we put receive buffer, never trust autocomplete, receive buffer to result, then we get all the slaves, but we assume that the master himself also does a calculation. So after we are done here, this is the local integral from the master is also added to it. Okay? Should hopefully work. So then we are almost done. The only thing is no, this is the wrong place. The right place is here. So, if we are not master, we are slave. And when we are slave, we have to do the sending, MPI send. So, what do we need to send? The value that has to be sent is the local integral. Local integral. So this is what we need to send. Then we want to send 1, and we want to send MPI double. And destination. So what is destination? I mean, I could say destination is 0, right? It's simple. The tag is also 0, and the communicator is MPI convert. So annoying. Okay, so then what happens? What we've already done is say my rank. If my rank is 0, then we get the result out. Okay. Since now we have apparently problems with the queue, I will MPI C++. How is this called? Main master slave minus O, and I still call this pi, and I compile this, and now I'm doing some, since apparently we have problems with, even though I just told you that you should not do this, but because this only takes 4 seconds, I'll do it anyway and run it on the login nodes. So MPI run with minus MP say 4, we run pi. Okay, let's see what happens. And this got stuck. Ah, wait, we have forgot something very important. We did not finalize. Okay, let's my rank. Okay, let's do this before we end here. So we have MPI finalize. So, okay, let's. You see, it did not complain at compile time. Okay, so now, I mean, this kind of makes sense, because before we used 4 seconds, now we use 4 processes, and it took 1 second. Yeah, okay. Kind of works, yeah. By the way, one thing that you observe, it's not, you don't get exactly the same error, yeah, because you are not adding up things in the same order. Okay, I guess I'll stop the recording now again.